and then we will look into what we can do with Drupal and GraphQL today. We'll see some actual live demos about Drupal together with GraphQL and a small setup that I prepared with some data models in a live Drupal environment. Right. So traditional REST. I'm going to demo most of the things that we'll see here in the introduction about REST and GraphQL using something called the Star Wars API. As you might have guessed, it's a tool that you can use to, demo REST functionality or GraphQL functionality based on real Star Wars data. And so for the beginning, since we are talking about REST, let's take a look at the traditional REST version of this API. Imagine you are interested in a particular person from the Star Wars universe. You want to learn about Luke Skywalker, so you fetch people1, the resource from that REST API. Now what you get in return is a huge pile of data. You might only be interested in particular fields from this resource, like the name, maybe the height, and the films that the person was starred in. So with traditional REST, you're somewhat limited to what the REST API offers you. So you make this API call and all that data comes back. So you're a little bit overwhelmed with the response. And now if you're interested in the movies that the person or the character was starred in, you'd have to make additional requests to the referenced API links on the films array here. So you'll do additional round trips to the API, which causes, especially if you are developing a client-side application that has to make these additional round trips, it causes like the data to drip into your application as you make these API calls. So it's additional overhead on the request side. Also, if you have an application like Drupal with a heavy bootstrap, this might delay the responses even further because every request on the PHP application causes this bootstrap and then fetches the data and then returns it subsequently. It's not ideal. So you might think that obviously if you take the model of REST a little bit further and build in some modifications or some custom functionality into your API, you can get around this problem. For instance, by adding a API resource very specifically for that one single request that you are interested in, so the persons and the movies that they were starred in. Or you might come up with a more generic solution with query parameters that can modify the response format. There are different shapes of that, so you can also, for instance, build something which includes a multitude of these additional fields. But all of these things are non-ideal, and they somewhat increase the complexity of your application, both on the client and on the front-end side. And this is not all. The complexity also rises as soon as you start developing multiple front-end applications. Think about a web application, Android application, or maybe different formats of the same application for the back office and the front office. It gets even more complicated if you start to add multiple versions to these applications. With all of these derivatives of the same API, you'll find yourself in a rising amount of complexity very easily. GraphQL is here to solve that problem. GraphQL is a querying language developed by Facebook. Facebook has been using it internally for quite some years now, and they've open sourced it about 2 years ago. They've open sourced it both in the format of a single RFC document, a specification which describes how GraphQL works. They've also open sourced a JavaScript library, which functions as a reference implementation and also as the main driver of the technology. So every time there's a new addition to the specification, it ends up in the JavaScript implementation first, usually. You can already use that to very easily set up GraphQL servers with Node.js, for instance. But there have been more and more languages adopting this recently. So we have PHP version as well, which is the one that we are going to look at later for the GraphQL implementation in Drupal. But yeah, let's see how this affects our queries. So again, the Star Wars demo, you can, by the way, go to this URL on your laptop if you have a laptop on you and try it out. But if we now try to do the same queries that we just previously executed on the REST API, we can now fetch all the people from the Star Wars universe. And for each of these, we can also fetch all of the films that they starred in. And from each of these films, we can take the title and only the title. Also, we want the name of the person. Sorry. So as you can see here, on the left-hand side, we have the GraphQL query. It might look a little bit funky to you because it is somewhat JSON, but also somewhat not. I like to think of this query as JSON without the values. So on the left-hand side, we are essentially providing the keys of the JSON that we want to get in return from the API. Because if you look on the right-hand side, you can see that the response is formatted exactly in the same shape as our query on the left-hand side. And noteworthy, it does not return any data that we didn't ask for. It only returns what we have asked for, nothing more and nothing less. How does this work? So when you first see this syntax, you might think, okay, this is another querying language, so it operates much like SQL or something like that. The main difference, however, is that unlike these database layer querying languages, GraphQL is actually an application layer data querying language. And that means that instead of directly accessing database fields and returning the values directly from the database, it actually runs code on your server. So that every invocation that we do here, and you can see that also in the syntax that we have on the screen right now, each of these fields in the query is actually mapped to a function on our server, and therefore it also has access to arguments. As you can see here, we are providing some sort of pagination functionality with the first 5 values from the people lists from the Star Wars universe. And all of these things directly map to functions on the server. And these functions are bound to the GraphQL syntax using something called the schema. The schema describes the querying possibilities on your application. And it is something that you can provide through code, or as I'm going to show you later in Drupal, through configuration. The schema is made up, or the schema functions as a graph. So you define types, you define interfaces, and you define fields which connect all of these types together. And it allows you also to traverse the graph, so you can follow references to other types through these fields. And it allows you to access the whole type system from your server through the schema. So yeah, it is based on a type system, and the type system describes the objects that in some way map to your data model in your application. Everything starts out with a root query type, and to that query type we assign fields. And these fields can have arguments. So in this example, we see that we have on the root a person field, which allows an argument of type ID, of type integer called ID. And when called, it will return an object of type person. This object of type person, again, has fields. We can fetch these fields. It can be string fields, it can be integer fields, or it can be connections that allow us to traverse further in the graph. So in this example here, we see that person has a connection of type films, also with arguments. These are just examples, obviously. You can provide whatever you want. And these arguments also have input types. So if I query films, I'll get a list of films in this case, the films that that person was starting. And I can traverse further. So the film itself is an object again. I can go back to the person. So there can also be some notion of recursion, and so on. Arbitrary code means that whatever you want to do with GraphQL is actually possible, since it runs on your application layer, and since it's just functions that you call, it's not limited to accessing values from your database. You can actually connect the field resolver, for instance, the Facebook API or the Twitter API, and thereby call external resources again from within your application code. You can compute values, you can render fields in Drupal, you can execute views, you can run rules, whatever you can think of is actually possible, and that's what makes it so powerful. So this is a pseudo example from the JavaScript framework, the JavaScript implementation, the reference implementation provided by Facebook. It's actually very simple to spin up a new GraphQL server using that I made GraphQL JS implementation. And you describe your schema using objects and function calls and class instantiation in the JavaScript implementation, as you can see here. So we have arguments on each of these objects. We have fields on each of these objects, and each of these fields can have arguments. And you describe them. For instance, this is a non-optional integer argument. And then you see that there's a resolver function. And as I mentioned, it's arbitrary code. So it's just a function that calls something, maybe a database API or something else that simply computes a value and then returns it. And what's also noteworthy about these resolver functions is, since they are embedded in a graph, they have access to the parent value. So imagine you are loading a node in Drupal, and then you have a field called entity label. It will simply, that resolver for the entity label field will simply get the parent entity, the node in this case, and all you will have to do inside of the resolver for the entity label is to call the label method on that object and return it. So as you can see here on the person type, if you want to fetch the name, we get the parent value. In this case, that's the full parent object, the full person object, and we just return the name property from it. It works the same in PHP, obviously. If you look at the GraphQL server from a bird's eye perspective, what we have actually is the GraphQL querying layer on top, which is the processor and parser that takes the syntax that you send a request, that you send within the request. That's just a string that looked like JSON that we saw in the first few slides. And it parses that, and it maps it to fields and types on your schema. So the schema is somewhat the glue code between your application layer and the GraphQL query language. And from that layer on, you can call whatever you have in your application layer. So you can directly map to the database. You can call internal APIs, or as I mentioned previously, you can also call remote APIs. This is quite handy, actually. Think about that one generic entry point to your whole data layer of your application, and you have a user object. And in that user object, in that user entity, you have a field which contains a Facebook API token, so that you can make queries against the Facebook API on behalf of that user just by providing a very simple function which calls the Open Graph API from Facebook using that API token. Because we have the schema and because we have the type system, we can use something called introspection. Introspection is a way for GraphQL to fetch information about the schema from your client-side application. The client-side application can therefore know what is possible within that application. It has access to the full schema. It can load the graph and all of the information attached to it, like descriptions, names of the fields, and you will know whatever is possible, whatever you can query from the server. And that's also what allows a lot of tooling on top of this ecosystem, like the GraphQL Explorer that we saw before, where I could run queries through a very simple browser tool with also type aheads and everything. And that all becomes possible because because of this schema, we get a generated form of documentation for our API. And we get that for free, just by providing the schema and describing our APIs in the schema. With GraphQL, and this is something that I find very important to understand, we are somehow evolving the relationship between the client and the server. With traditional REST, the server provides resources and dictates the format of the response based on whatever code runs these resources. With GraphQL, we describe our schema once and publish this schema, thereby the possibilities of querying within our API. And then the client can explicitly specify concrete data requirements against that schema and fetch whatever they want within the boundaries of that schema. So all of these problems that come with traditional REST, especially in applications with very sophisticated data requirements, somehow go away. Like you don't have overfetching, as we saw before in that example. We don't have underfetching, as we also saw in that example before, where we have to run these additional queries against that film's endpoints. So, as I mentioned, GraphQL has been published in October 2016 as a formal specification. It is a very long document. Actually, this is GraphQL. So GraphQL is not a concrete implementation in any particular language. GraphQL is just this document which describes how a GraphQL server should function. And since that GraphQL.js implementation has been published, a lot of other libraries have been published afterwards. So for instance, we have a C implementation, we have a Elixir implementation, we have a Scala implementation, we have a Python implementation, we have a PHP implementation, we have a Ruby implementation, we have a Go implementation, Java implementation, and we have a Drupal module. And this Drupal module runs on that one PHP implementation that I mentioned before. And it simply exposes a lot of the Drupal data models through that schema that I mentioned, using that PHP implementation. The Drupal module has been open sourced a while ago, actually very early after the initial release of the first PHP implementation. But it has undergone a process of rewrites, refactorings, and improvements over the course of the last month. And we are now in the third version as we are working out how to actually expose all of the Drupal data types in the most efficient way. And with this third version that we have now and the alpha releases that we have published already, we are very confident with this module. And we're actually using it also in production already, using together with React client-side applications. So this is what we use as our foundation on the Drupal side for decoupling Drupal and creating completely headless front-end applications with Drupal. The module is hosted on GitHub. It is also being developed on GitHub, so we have closed the issues on Drupal.org, and we are running all of the features for issue tracking and so on GitHub directly. If you are interested in contributing, feel free to join us. We also have a Slack channel on the public Drupal Slack. We're always looking for contributors, and we're also actually very active on the Slack. So if you're trying it out for the first time or if you have questions, just come by and ask us. Usually we're very responsive. And actually, since we are in the same time zone here in Zurich and also in Austria, where my co-maintainer lives, we'll be able to assist you with whatever you have as a problem. So, we looked at some JavaScript examples before, but what if we want to now have a schema in Drupal, and how would you expose such a schema in Drupal? So if you have a query and you want to load a node, for instance, by ID, we have that argument again for the node ID, and then we have a few generic fields. All of this stuff is generated by the module for you. How does that work? So we have a plugin system underneath, and it uses the traditional annotation discovery from Drupal 8. Oh yeah, by the way, this is a Drupal 8 only module, so if you're on Drupal 7, I'm sorry, there's no No work on that for Drupal 7 currently. But yeah, in Drupal 8, we use the plugin architecture provided by Drupal core to allow you to register fields and types and interfaces for your GraphQL schema. So you can provide a class which simply has a resolve function, and that resolve function is described and registered within the plugin manager using this annotation. So you describe this plugin with a name, you provide arguments, all of these things are then generated into the schema. And then the resolve function is called with the parent value and all of the arguments that you provided within your query. And then you can run code. So in this case, we are using the entity storage of the node. So since this is a derived field, we are generating the same field for every content entity type in the system. And then you call the storage for node, for instance, load the entity associated with the ID provided from the arguments, and then we return that entity. Subsequent fields on this type can then also expose the label, the bundle, all of the fields associated with that type, and so on. And as you can see, also there's caching built in. So we support caching and full cache tags, cache context, and also cache invalidation. So we have very fine-grained cache control built into the system as well. The module itself comes with a series of sub-modules. We're actually currently in the process of simplifying that and merging most of these modules together into the GraphQL core module. But all of these modules function and work together to generate a huge or a full-blown GraphQL schema based on whatever you have currently enabled and configured for your data structures in Drupal. It will expose all of your content entity types if you wish, because you have control of what is being exposed. And it will expose all of the fields and entity properties, as well as some internals from all of these content entity types automatically. So you enable the module, you configure what you want to expose, and then you can start querying without writing a single line of code. So in this example, we see that we can run node queries or entity queries for each node type, or sorry, entity type. And then using this fragment notation, we can narrow down on the types that are being returned from each of these things. So in this case, I can actually say if the return value is node of type article, access the field tags on that article, and that tags field is a reference to the taxonomy vocabulary tags. So I can actually look up the labels from the taxonomy terms associated and linked to that article. Right, so without much further ado, I'd like to show you how all of this works in a real demo application. So I've prepared a very simple Drupal installation using the GraphQL module. We are going to look at a few of the core features, so whatever the GraphQL schema can generate for you based on your configured nodes and entity types. And we will also look at some other module integrations, so we'll look at views. If we have time, we can also look at things like search API and indexes together with views as well. We can look at how the different field types can be controlled within the GraphQL schema to format the schema differently. And yeah, let's have a look. So as I mentioned, now that we have enabled the whole GraphQL module suite in Drupal, we can actually use these visualization tools from the GraphQL ecosystem. So I have my schema here. This is the default generated schema. As you can tell by this user interface, it's possible actually to expose multiple different schemas. And it's actually also possible to generate multiple different schemas. You always have the option, of course, to customize or to create a completely custom schema purely through code. Our goal, however, is to generate this for you. And actually, there's work being done to even provide more fine-grained control of this configuration so that you can really go in and explicitly specify for each single field whether you want to expose it, with what permissions you want to expose it, and with what configuration you want to expose it. This is very complicated also because of the user interface that would be required to build such a graph. You know, graph interfaces are always very tricky. But with the solution that we have currently, it takes away a lot of that hassle. It just generates the schema, and it comes with a few assumptions, so it generates a lot for you. And the schema might be a little bit bigger than you expect. There might be more things exposed, and there's not 100% control yet, but we're working on that. So if you see, if you take a look at the schema that you generate, that is generated for you here, that's what you get out of the box. And I've configured something close to that example that we saw with the Star Wars API. So I have two content types, a movie and a character content type. Each of these has a few fields. So the character content type has hair color. It's a Boolean field about whether or not that person is a Jedi. And a reference field to the movies and some other fields. The movie type has just two fields. The length of the movie, I just added some guess values here, and the opening as a text field. We can find these in our schema here. So there's now exposed a character type. It has all of these core properties also, but it also has the fields that I created here in the schema. So the species is a reference to a taxonomy term of type of the vocabulary species. And there are string fields like if someone is a Jedi, and the hair color, etc. I can now also use that other tool that we saw before, the graphical interface, and I can run queries on the schema now. So I can fetch using a node query and it allows me to filter based on the filterable or queryable entity properties all of the entities or nodes of type movie. We have two movies in our system. And then for each of these, I can retrieve the label. So these are the two movies that I've previously created here. So A New Hope and The Force Awakens. And this is cached now because I've run this query once. And now I can, using this fragment notation, further traverse and access the fields which are associated directly to that movie bundle. So I can now fetch the length of the movie. I can fetch the text from the opening crawl. And this is now a very interesting feature in my mind, we have support for views. I have prepared two views, actually three views. There's one view which simply returns a list of movies. So instead of using that entity query, I can also query this view. And that's just the configuration that I've prepared inside of this view. And because in this view I have an exposed filter for the title, I can actually run filtering now based on that view's configuration. I can say, give me everything with title Force. And we'll just filter that. Now, because I'm using an entity display in this GraphQL display, for the view, this gives me access to the full entity schema that is also generated for the node query. And I can say, give me all of the characters from this movie. And for each of those, give me the label. How does this work? Well, I have another view, starring characters, which takes a contextual argument of type node with a reference to the entity reference field that I have created on the character. So because we detect that there is a contextual filter of type node, we directly attach the starring characters view to the node, to the movie bundle, because it can be used to filter this result. So the parent value from here is injected as the contextual filter on this view, so I can control the schema with the view configuration here. And I can also here now narrow down further on the character, and then fetch fields like light side, dark side. And I can even traverse further and say, okay, give me the species. And that's now an entity reference field on the character, which links to the taxonomy term. So I can fetch the taxonomy term label. Obviously, I can also fetch things by their ID. That's the movie. And something very important also for the way that we decouple Drupal, we can load all of these things through the route definitions. So node 1, the route from Drupal, returns an entity, and that's the fourth awakens. There are multiple other ways of running queries here. For instance, now because I have access to this route, I can run the breadcrumbs. And for each of these breadcrumbs, again, I can fetch the entity associated to the target URL. In this case, well, we don't have a breadcrumb, so, but yeah, I can run contexts, so I can fetch the node context from that URL. Obviously, in this case, it's the same because the URL itself is a node. I could also fetch the active user object through the current user context. And much, 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 much more. We generate this schema based on the plugins that we provide in the module. So if you want to have an additional custom functionality, you can just write your own plugin, derive it, or whatever. That's all very simple through this plugin system that we have built in. But everything that you get out of the box from the module allows you to build a whole API, and for the decoupled frontends that we have built so far, it's more than enough. All right, so we have 10 minutes left, I think, if I'm not mistaken. Is that correct? Yes, I see you nodding from Inky. That's perfect. I think it's time for questions. Otherwise, we'll not have enough time for that.
Cool. Does anyone have a question? Anyone? Have the mic.
Just in the stunned silence. Fuhby, do you want to maybe show some examples of real life stuff, like the stuff you've been doing for Rush?
For Rush?
Of what GraphQL and React can really do? Okay.
Well, we have a client that has built, together with us, a completely decoupled React application based on Drupal and GraphQL. So for this client, we have one single Drupal installation. That Drupal installation serves as the central content repository for the publisher. It's a huge publisher with multiple magazines and online magazines. And a few of these websites have since been rebuilt using React and GraphQL. And they all use the same GraphQL backend running on this Drupal installation. And the Drupal installation serves as that one single entry point for all of the journalists working for this publisher. So we're using the groups module here to control content streams for the different online magazines. So this Gomeo website uses a different publication, a different group publication stream to fetch all of the content associated with that website, and Beobachter also uses a different one, obviously. And then all of these things here are generated with React, and they run GraphQL queries to fulfill the data dependencies of this front-end application. And as you can see, it's running very fast because we are really only fetching that information that is required for each specific page. What's noteworthy with GraphQL and React in tandem, we can actually build these front-end applications in a way that when I do route transitions, instead of running full-blown requests on the server again, we are actually just fetching the data dependencies of that next page. So since we have already generated the menu once, and since we have generated the footer once, we don't need to refetch that when we transition, when we transition to a new page. What we need to do is we need to run a GraphQL query that only returns the data that has data dependencies that have changed between route A and route B. So for the next route, we are only fetching whatever needs to be fetched for this route. So here you can see we are fetching the group content. And then it returns the route object, which is the entity in this case. We can fetch the breadcrumbs here. The body text. The body text is split up in paragraphs. So we have React components for each of these different paragraphs here. And yeah, all of that data is composed on the backend through our GraphQL schema. The same works here on Gomeo. So if I make the route transition, you can see that all it does is it runs GraphQL queries. Maybe also noteworthy, like you can see all of the cache tags here in the response. So all of that works also through the CDN. And also, if you look at the query here, we are not actually sending a query string. We're just sending an API version and an ID of the query. That's because we have cached the queries on the server, and the server knows which queries the client-side application needs. This concept is called persisted GraphQL queries. It's a JSON file that lives on the server, which has all of the queries organized in a map with keys as IDs. And then when we send this request with that API version and the query ID, the server looks up the actual query string from that JSON file and runs it. That's how we can somewhat obfuscate the API and disallow like arbitrary queries against our API. We'll just allow things that the server has knowledge of through our build process. So during our build process, we extract the GraphQL data dependencies from our React components. We generate a JSON file, we send it to the server, and at that point, this application, this client-side application, is allowed to run the queries that it needs. So if you will, we are kind of versioning our API based on the code that we write in the front end. Every time we commit a new version of the front end, a new API version is generated on the server based on the data dependencies of the front end. Yeah, I don't know. I can show some more fancy, funky, maybe crazy things that we can do with GraphQL and Drupal, like fetching JSON or extracting XML values from HTML, for instance. Unless there are questions now.
Yeah, I've got one from back here.
Okay, cool.
Hi, Fuhby, it's Lise.
Hi.
I have a question. You're very focused on React. We all love React at Amazee. What is it about React that you're always using it instead of something like Vue? What's your opinion on Vue.js?
I don't have anything bad to say about Vue.js. My preference for React is not because I dislike the other solutions that are out there. There are multiple other very viable options like wow, even if you are really into bleeding edge, you could use BuckleScript or ReasonML, whatever, to write your front end, and it's probably more technically sound than pure JavaScript and React. But what I specifically like about React is the ecosystem around it. So React has somewhat transformed the way that we think about JavaScript front-end applications and interactive UIs, because the JSX, as much as people hated it initially, allows us like to think of our components much differently than we used to before, and it has attracted such a huge amount of developers that the ecosystem has grown to a point where you can very easily build very complicated applications and leverage all of the existing libraries that you will find on NPM and on GitHub to really quickly put together a very, very, very nice application. With Vue, I have my reservations because I don't like, now I'm saying it, I don't like the templates, the template ideology that Vue brings back on the table. I really enjoy the fact that React moves away from this traditional MVC model by co-locating components and styles and logic and giving you the complete freedom to control how you do that. Templates are a thing of the past in my mind. It's very intuitive to write JSX components and co-locating them with your application code. And that's what's so appealing to me with React.
Cool, thank you. Anyone else have any other questions on GraphQL, 8 and React, or any other hitless kind of questions? No, I think that's it then. Cool. Fuhby,
Cool.
thank you so much.
Thank you very much for the opportunity, and thanks for allowing me to do it remotely.
Cool.
It's the first time that I've done a remote presentation. So.
Cool.